Assalamualaikum. My name is Noor Syaza binti Ridzuwan. I am a student of School of Science with Education. I am the presenter of the group.
And I'm Miss Fikriyah binti Mulyadi from School of Physics, and I am as the script writer.
Assalamualaikum. My name is Asyiqin binti Ahmad Mokhtar. I am from School of Science with Education. I am the editor in this video.
Recently, I have watched a video about SLSC. So basically, SLSC is US National Particle Accelerator Laboratory. The main accelerator is Radio Frequency Linear Accelerator, or we call it as LINAC. So let's watch this video. Hi and good morning. I am Noor Syaza, your host for today. Here, we bring you to one of the biggest research center, SLSC, National Accelerator Laboratory, that is located in Menlo Park, California. So, let's check out what they offer inside. Let's go. So, guys, this is a rare view from inside of the SLSC site. Now, I'm with one of the workers here, Mr. James. He's going to show me around the site. I believe this is the famous 3.2 kilometer linear accelerator. Wow, I can't imagine this tunnel is more than 3 kms, but looking from this section alone, it's huge. So can you tell us in detail about the physical elements of this LINAC? Yes, this is just a part of the LINAC. Well, it's not just a long 3-kilometer pipe located in a tunnel 25 feet below the klystron gallery, which houses the klystrons and energy doubling cavities made of high-purity copper. The linear accelerator facilities is comprised of other subsystems as well to keep its safety and as hazard control. So this is a rough schematic diagram of the LINAC. Today, there are other types of particle accelerator. Here we focus more on the linear accelerator for various researches that have been done here. Alright, Mr. James, can you share what are exactly the duties of each part connecting to LINAC main accelerator body?
We are actually standing below the klystron gallery. As I mentioned earlier, the klystrons are vacuum devices that amplify radio frequency signals to produce high energy particle beams. And from the left side of the map, we have collider injector that will produce electrons in short pulses at a repetition rate up to a maximum of 120 pulses per second. This LINAC also has the north and south damping rings, which to control the emittance of electrons. After collider injector, we have the extension of LCLS injector from the existing LINAC to produce an intense coherent X-ray beam by transporting a compressed beam of electrons through a magnetic undulator. The NIT and SIT here refers to north and south injection transport. They are vacuum chambers that advance through a connecting tunnel to the PEP2 storage rings. NIT specifically transports electrons to the high energy ring, or we call it as HER, or SIT on the other side transports positrons to low energy rings, or we call it as LER. HER and LER are the PEP2 storage rings that I just said. Now, these Station A, or we call it as ESA, is a facility for experimental physics and test beam activities involving electrons directed onto fixed targets. The transport system delivers beam to ESA up to the full energy of the linear accelerator. Beams may be transported through the end station to an underground beam dump. Beam dump is, or we call it as BDE, on the farthest right over here, some 200 feet further east. That is basically the overview of the plan of LINAC, more or less.
Well, you say that LINAC, or linear accelerator, is one of the types of particle accelerator, right? So what about the other type? So basically, particle accelerator has two types, which are linear and circular accelerators. But here in SLSC, we only handle the linear one, this big guy. But can you tell me what are the differences between linear and circular accelerator? So linear accelerators propel particles along a linear or straight beam line. For circular accelerators, on the other hand, propel particles around a circular track. Linear accelerators are used for fixed target experiments, whereas a circular accelerator can be used for both colliding beam and fixed target experiments. Very well. Well, sir, you've told us about the overall view, physical view of the linear, but what really is the working principle of linear, or in the other words, how does a linear work?
In a linear particle accelerator, drift tube has positive potential, while electrons have negative potential. A bunch of electrons are accelerated to the drift tube because of this potential difference. RF source changes its polarity as soon as the particles enter the first drift tube. Hence, the first drift tube becomes negatively charged, but the second drift tube is positively charged. The inertia of electrons makes them come up from the drift tube, so electrons are pushed into the first tube, and at the same time, they are attracted to the second tube in the same direction. Meanwhile, electrons' velocity turn bigger because of their acceleration. So this is the reason why drift tubes are longer. Speed of electrons increases as soon as electrons come closer to the target. Lining is long because of longer drift tubes, and the number of tubes is so high.
So my last question for today, is there any main advantage and disadvantage of using linear accelerator? The main advantage of linear accelerator is that the particles are able to reach very high energies without the need of extremely high voltage. But the disadvantage is that the particles travel in a straight line. Each accelerating segment is used only once. This means that the only way of achieving particle beams with even high energy is to undertake the expense of adding segments to the length of the line. So, Mr. James, thank you so much for spending your time to answer my questions and show us the line. You are welcome, and we are so honored to have you all. Unfortunately, Mr. James, we don't have much time to show our viewers the overall view of this place, but I'm pretty sure our viewers have gained a lot of information for today. So stay tuned for the next episode of Majalah 3. Goodbye!